Hey guys, this is Ashwin and you're going to tell us something about stacks.
Hi guys, I'm Ashwin. I'm in my third year studying along with Vaishnav here. Okay, so starting with the basics, why do we need data structures? Data structures are it's a concept on how we store data. So we might need a specific structure to store some specific results, right? So let's take a daily example to understand what this data structure over here is. Stack, right? So we go to the mess every day and we eat food from them. So in our messes over here, we have plates which we can take a plate, we wash it, we use it, and then we keep it back, right? So you have a pile of plates. So you go to the mess, you take the first plate, use it, and then you keep it back. Your friend comes after you, he takes that plate again, right? So whatever goes in first comes out first. So that is exactly the principle of this data structure. Stacks. First in, first out. So let us first see what are some practical uses inside the operating system, right? So you might have heard about functions and how multiple functions work together, right? So what happens when one function calls another function, right? So only one function can execute at a time in the OS, right? So when a function calls another function, all the information of this function needs to be stored somewhere. So let's say we have a data structure like this. This is obviously a stack. We are learning about stacks, right? So we have a stack over here which will hold all the information about this function so that we can move on to the next function. So function f1 calls f2. So all the data of f1 gets stored in the stack. Now f2 starts executing, maybe it calls another function f3, and all information of f2 goes inside the stack. After f3 gets executed, where does it look to return? It just looks into the stack. So what does it see? It sees f2 and its information over here, right? So it is taken back and then that part resumes execution. Now after f2 gets executed, it again looks into the stack. Once it looks into the stack, it sees f1 and then f1 starts, it resumes its execution. So this is how stacks are practically used in our inside the operating system. So pause it and continue. So stacks is an abstract data structure. It does not matter if we use an array or if we use a linked list. The advantages and disadvantages may vary, but we do not have to bother how it is implemented. So to use a stack, the three main functions that we see is something called push, top, and pop. So no matter if it is implemented as an array or a linked list, the overlying functions of a stack will be this: a push, a top, and a pop, and maybe a size function as well. Right? So what does a push do? It inserts a new element into the stack. So as per this idea of a stack, can we access an element in between? No. We can only access the topmost element of a stack. So if we have a stack with a few elements in it, we can only access the topmost element. So that is what the function top does. When you call a stack s.top, you'll be returned with a value that is stored in the topmost element. Now when you push, that element is added over that. And when you pop, the topmost element is removed. So we just saw how a basic stack works. We did not bother about implementation because this data structure over here is an idea. And when we have ideas like these, we do not have to bother how it internally works. As long as we know what is important to work with these structures. So stack is a structure that we learned initially, and it is a stepping stone into learning more such data structures. So that's all for today. Thank you.